Hey, welcome to Lessons with Mr. Clark. Today we will be learning about multiples. All right, let's jump in, shall we? What are multiples? Well, first we got to understand what multiplying is. Multiplying is just repeated addition. We're adding the same number over and over. It is a shortcut to add. Okay. So, if we look at this next, we have 3 plus 3 plus 3 plus 3 plus 3 equals 15. We have repeated addition. So a shortcut is how many 3's do we have? So it's 3 times 1, 2, 3, 4, 5. 3 times 5 is 15. That's how we can get there faster. We could also write it as 5 times 3. They're the same thing. 5 3's, 3 times 5. All right, so when we have the word multiples, when you think multiples, we look at the base word, we think multiply. Okay, so over here on the right, the multiples of 13. We're going to do 13 times 1, 13 times 2, 3, 4, 5, 6, 7. We could do this forever. So 13 times 1 is just 13. That's the first multiple of 13. And we only do whole numbers as multiples. 13 times 2 is 26. 13 times 3, 39. 13 times 4. I don't have that one memorized, but I know 13 times 3 is 39, so I'm going to add 13 to that and get 52. 13 times 5 I do have memorized. That's 65. 13 times 6, well, I'm going to add another 13 to 65. That would be 78. And then lastly, 13 times 7 is 91. Okay, we could keep going on forever. 13 times 8, 9, 10, all the way up. But these are the first 2, 4, 6, 7 multiples of 13. Okay, the next concept, least common multiples. You will also see this written as LCM, usually all capitalized without decimals. All right, the LCM, it's the least, so another word for that is it's the smallest common, so number that is shared on the list of numbers, or of multiples, I'm sorry. I should write the word multiples here. Smallest number that is shared on 2 lists of multiples. Okay, so the LCM of 6 and 10, multiples of 6. We can count by 6's, or we can do 6 times 1, 6 times 2, 6 times 3, and we just need to do this for a little while. We don't need to go forever. Multiples of 10, well, that's easy. We just count by 10's. And again, I could just go for a little while. Now, do we have any that are shared on both lists? Yes, we do. We have a 30 here and we have a 30 here. So the least common multiple of 6 and 10 is 30. Okay. If we just wanted to find a common multiple, well, the easiest way to do that would just be to multiply 6 times 10. 6 times 10 is 60. That's in common with both of them, but that's not the least. 30 is smaller than that. Okay, over here on the right side, the least common multiple of 5 and 7. We know one common multiple of 5 and 7 would just be 5 times 7, 35. Let's see if there's any smaller than that. So the multiples of 5, you should be able to just count by 5's. And we don't need to go past 35 because we already know that's one common multiple. Multiples of 7, 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. Well, there you have it. We couldn't find any smaller. That is the least common multiple, 35. Okay, let's do a least common multiple of 3 numbers now. We have the numbers 9, 2, and 12. Yes, we could multiply them together. 9 times 12 is 108, times 2 is 216. Well, we sure should find one smaller than that. Let's first list some multiples of 9. So you could just keep multiplying 9 in your head. You can probably do this faster than I'm writing right now. 72, 81, 90. Okay. Multiples of 2. Well, this one's interesting. We know that every even number is a multiple of 2. So I'm actually not even going to write all these multiples of 2. That would take me a really long time. Plus, I know that 2 goes into 12. So if it's a multiple of 12, it's also a multiple of 2. So I'm just going to ignore that. And I'm just going to write my 12s. And if you know in terms of dozens, it makes your life easier. It's good to memorize these 12s. All right. Do I have any in common so far? Looking at both lists. Yes, we do. We have the number 72 on both of them. We could get all the way up to 9 times 12, which is 108. But we already have one that's smaller than that, so we don't have to go any farther than... oh, you know what? Look. I got to look closely. I almost made a mistake. 36 is on both lists. There we go. So the least common multiple. And we know 2 fits in here too, right? If we keep going on 2s, we'll get 36. 36. Here's something else that's interesting. 36 times 2 is 72. 36 times 3 is 108. So we're going to keep having these multiples of 36 be on the list as we go too. So there are other strategies to do this too. That's just one. List your multiples until you find the least that's in common. Don't go forever. All right, let's do a word problem with this. Okay, Donna and Kareem are both in middle school track. Donna runs each lap in 2 minutes. So we think about Donna here. Every 2 minutes she's making a lap around the track. So 1 lap, 2 minutes, 2 laps, 4 minutes, 3 laps, 6 minutes, 4 laps, 8 minutes, 10 minutes, 12 minutes. She keeps running every 2 minutes. That's Donna. Kareem walks. He's a walker. Each lap in 5 minutes. Come on, Kareem, you're on track. So 1 lap, 5 minutes, 2 laps, 10 minutes, 3 laps, 15 minutes. And we could keep going on this for a while. The 2 of them begin at the starting line at the same time. So they both started together. So Donna's done in 2 minutes, Kareem's done in 5. Donna actually finishes 2 laps before Kareem finishes 1. All right, so let's understand that problem. So now let's answer these questions. How much time does it take for them to meet again at the starting line? So for them to meet again, they're going to have to be in common. There's got to be a common multiple. Do you see any common multiples on our list? You should. Here it is, 10. So how long will it take them to meet again? 10 minutes. How many laps will Donna have completed by then? Well, we could just count 1, 2, 3, 4, 5 laps. She'll be done with 5 laps. How many laps does Kareem finish? Well, 1, 2. Only 2 laps. That's all right, Kareem. Let's get you in shape. All right, so in conclusion, today we worked on multiples, mainly common multiples. Thanks for joining. Hope you have a great day.